and list of single letters. Might be repeating also. I'll show, because you can see that this is the words, this is the letters, and this is the score. So they are given the list of words. So I'm giving some list of words. So here I have 4 words. List of single letters. As you can see, I have some single letters: A, A, C, D, 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 G, O, O. So they are repeating also. Okay. And a score. So every character they have given a score where the score is 0. Okay, for that character, as you can see, for B the score is 0. Okay, the score is 0. For A the score is 1. For C the score is 9. This is a score for every character. Okay, I have to return the maximum score of any valid set of words. Again, this is a set of words. I have this words. I have 4. I have 4 words in this words string or in this words vector. I have to choose any set of words out of these 4. I am asking you to choose any set. Now any set, again, you can think of it as any subset, right, of words formed by using the given letter words of I and cannot be used 2 or more times, which means I can make a set out of it, which means, okay, I have this dog, cat, dad, God. I can make a set. I can make only dog and cat. This is one set, which is same way saying this is a subset of my words. I can make a dog dad. This is also one set. According to them, this is one set, but for us, we know it is one subset of my words vector. And again, they're specifically saying you cannot repeat that specific words of I, which means I cannot say my subset is dog, dad, dog. I cannot repeat my dog. That's a basic thing of a subset also. So they have not directly mentioned it is a subset, but we can easily infer from this statement that this, what they're asking us, maximum score, they are asking us to form a subset. And ultimately, they have written a condition, which is a main condition, and saying that it is not necessary to use all the characters in the letters. So it is not necessary to use all these characters. Now, they're just given as something to showcase, but they have importance. They have importance as each letter can only be used once, which means, let's say if I'm using a dog, so I will say, okay, dog, I have, can I do, like, do I have a D? Yeah, I have a D. Do I have a O? Yeah, I have a O. Do I have a G? Yeah, I have a G. Okay. And again, let's say in the same subset, I'm choosing a dad also. So do I have a D? Again, this D has been taken and I'm choosing in the same subset. So, okay, I have another D. Do I have a D? Yeah, I have another D. Okay. Do I have a? Yeah, I have a. What if I choose to take this as another subset? Do I have a G? Yeah, oh, I don't have a G. Because in this subset where dog and dad are already taken, I cannot incorporate another good. Why? Because G I don't have. Neither I have extra D. I have O. I have one O, but still I don't have one more O. So that is what we need to incorporate to make sure that we are taking, and this is what they mean, that we can take that letter only once. Okay, so now our main task, that I want maximum score out of all the subsets which I can form. I know that if this is words, this is of length n. I can easily generate 2 raised to the power n number of subsets. Now, to generate these subsets, we have 2 ways, and these are fixed ways. One way is, again, these are 2 raised to the power n number of subsets which I can generate. If you don't know what subsets are, it is okay. I have 2 options. Either I take this or not take this, take this or not take this, take this or not take this, take this or not take this. So this is saying that I will have 2 options for every word. Thus, I will have 2 raised to the power n number of possible subsets. Now, to actually generate all these subsets, I have 2 options. Either I can generate it via recursion, or I can generate it via masking. Now, if you don't know what masking is, please go and watch this video. If you know it, and if you're confused how to generate these subsets, go and watch this video. Cool. Now, coming on back, masking just helps me to say, if I make a mask from 0 to number 7, let's say if I'm saying I have 3 words and I want to generate all possible subsets, so I'll generate all possible masks for these 3 places. For these 3 places, we can easily say I will have 2 raised to the power 3 minus 1 as the last number, which is 111, which is actually 7. Mask is in a binary form. If you're confused in any of the stuff, please go and watch this video, and for practice, go and watch this video. Now, coming on back, I know that I can easily get the numbers from 0 to 7, which means 0, 0, 0, 0, 0, 1, 0, 1, 0, and up till so on 1, 1, 1. This easily says that I should not take the first, this says I should not take the first word, I should take the second word, I should not take the third word. This is what the mask help us to make. And if I choose recursion also, we simply know that, as we simply saw, it is a take not take stuff, right? So I can simply say, okay, I can simply ask my recursion to solve, this is the index, and let's say this is my words vector. So I can simply call my recursion by saying, in the, again, same way, if I take the specific word, which means here words of I is, let's say, taken. Okay, it is taken, and then I will go and simply call for next word I plus 1, and again passing the same words vector. Or if I can skip that specific word, which means I will just directly move on to I plus 1. Again, operation will depend. Operation will depend. Here I just added this, but this is not okay. Operation will depend. You can push in the vector also. There are multiple stuff. So this is how I can use recursion itself, and this is how I can generate all the possible subsets by using mask. Although in most of the problem, I always recommend to use mask. You can also use a recursion, but make sure you know how the time complexity will work. But on top of it, whenever the things like subset comes in and we are using recursion to incorporate those subsets or maybe apply operations on those subsets, we can maybe improvise our recursion with backtracking to improve the complexity. But I always suggest to firstly go through and build all your possible subsets by using your mask. This is usually most optimal also, and it is easier also in many problems. Cool. Now coming on back, again, people might think recursion is easy, but the more you go on to the masking stuff, the more you will get familiar with it. Again, I'll show you both the approaches, but still I'm telling you how much importance everything gives you. Now coming on back, we know that we have to generate all these subsets. We will take a 2 to the n time to generate all these subsets. Now when a subset is generated, I have to go on again. Let's say a subset is generated, and I know in the worst case a subset can have n words. I have to just make sure for those n words, and let's imagine that every word has a length of L. So I have to make sure that all of these characters, in total I will have n into L characters, right? In this n words, every word having a length of L, I will have n into L characters. I have to iterate on those characters and have to make sure that the frequency, because again these are n into L characters, which means I can have A, let's say 4 times, B 5 times, but I will have only 26 characters, but they have their corresponding frequencies. So I will just maintain these frequencies. For every character, I'll just maintain the frequency, and I'll just check that I should not exceed this input frequency. Letters is the input frequency, like letters is the input limit of every character. As you can see, A has a limit of 2, C has a limit of 1, D has a limit of 3, G has a limit of 1, O has a limit of 2. So I should not exceed this specific frequency for a subset which I have taken. So I'm showing you, n is the worst case. It can be 4 also. I have only, let's say 4 words. It can be, okay, I have only, let's say 2 words. So for all those n words, again, n is the worst case, I have to go on to every of the individual word. Individual word can be of length L. I will grab the frequencies, and I should make sure that this frequency, which means the subset which I have taken, should have lesser number of individual characters than what is given, lesser or equal. If let's say let's say for this specific subset, I am asking A to be a frequency of 4, but I only have 2, that is not a valid subset for me. That's not a bad subset for me. So I should simply ignore, and I'll try for different subset altogether. Thus, you will see that what is the complexity now? You will firstly generate all the possible subset to the power n. Then for a specific subset, I know in the worst case, it can have n words. Again, I'm saying for a specific subset right now. And every word can have a length of L. So this will be the complexity. Will this work? Let's see. So my n is 14. I have 14 words, which means 2 raised to the power 14. Now I know that for again, this is again n into the length of each word, it is 15. This will very easily pass in a time constraints. So okay, this will work. So now I can simply apply my masking approach to generate all the subsets. You can also apply the recursion approach, but make sure I'll tell you what the drawback of recursion is, but you should have watched the drawback of recursion. Recursion drawback is that you keep on copying the entire data structure at every level. Want to understand more? Please go and watch this video. Now, so let's see the simple masking approach. It simply says that firstly, I have these words, I have these letters. Again, I know letters are A, B, C, D, D. So I generated these letters into a letters map, saying A has a frequency of 2, B has a frequency of 1, C has a frequency of 3, like this. So I went on to make a letters map in which I will simply iterate on all the letters and will simply make a frequency map for it. Now, same way I will do for the scores. Again, although you can directly use scores also, because scores is a vector. Scores is a vector which is directly given to you, that okay, at the index 0 it is the frequency of A, at the index 1 it is the frequency of B, at the index 2 it's a frequency of C. So you can directly use, and you can say okay, score of, let's say if I want to know the, let's say, score of character C, so I can simply say score of index which is okay, C minus A. This will give me the score of character C. If I want to know the score of character D, I can know it by simply doing a D minus A. This will give me a score of character D. But okay, for simplicity or for showing you the multiple ways, I just converted that score to a score map, right? I've went on to all the input characters or input I equal to 0, 1, 2, 3, which represents A from A to Z. Then I just simply grabbed and told, bro, this is for a frequency, like for a character A, the frequency is this. Okay, now I got this score map. I'll simply now generate all the possible subsets by going on and trying for all the possible masks. Now I will maintain the current word map. Why this is needed? As I showed you, if I have grabbed a subset, okay, if this is one subset, I should know what is the current word map, which means whatsoever I have taken, whatsoever subset I have taken, I have to maintain the frequency of all the characters in that subset. So that is how my current word map is needed. So I will take the current word map, and now I will iterate on all the input of my words n, and then if that index is matching my mask, it is how we represent it. Again, if you have end out, go and watch the bit manipulation crash course. Then we will simply take that specific index. I will take, again, if this is true, I will take that specific index. When I say take it, I will simply incorporate that all the characters in that words of I in my map. Now I have grabbed, up till this point I have grabbed my entire word map. Now I have to validate that if the frequency in the word map should be less than or equal to my letters map, because this is the main bottleneck for me, letters map. So I will mark is bad, false. I will simply iterate on my word map, current character and frequency, and I should make sure the frequency, if the letters map frequency, if it is less than my current word map frequency, I'm screwed up. So I will make is bad equal to true, and I'll simply break, because it is not a good subset for me. So okay, sorry, it is repeated, it just copied same thing. But yeah, now what I will do, I will again, this is when I was cropping the image, right? Now I will make sure, okay, if the bad is not, which means okay, it is not bad. If it is not bad, the subset is not bad, then I will get the current score of the current subset. I know all the characters and the corresponding frequency also in the current subset. So I will simply take the frequency, I will ask the score of that character from my score map, and I will maintain my current score, and I just have to maximize my score. I get the maximum score. just maximizing my score. Again, maximum score and the current score. With this, I will get the maximum score for all these subsets. To know a subset is good or bad, this is what I have done. That's it. Cool. The complexity for this is again 2 to the power n to generate all the possible, as you can see, all the possible mask, all the possible subsets. For every subset, I am actually, again, for every mask, I am trying to know what all possible indexes are there. It says I have to iterate on all the possible, like indexes. So it will incorporate a n time. It is at a 2 to the power n, and then for that I will go on to every character on that word, which is L. So it will be 2 to the power n into L. So it will be 2 to the power n into L. Again, space, we are using only map. This is the only space used, right? These letters map, again, this was not even useful, like this was not even used, like I should say it was not required as such, so I can just simply ignore it, but this is the only thing which was used. Letters map, that's it. So space is 26. But can we improvise it? We can think of it. How to think of it? When I was showing you, if I would have applied recursion, then the recursion simply says go and try for the next I plus 1, and then do something with your current words of I, which means recursion will for sure incorporate at a complexity of 2 to the power n. That will for sure come. But for me as a person, if I am trying for a specific subset, okay, I have two options. I have, let's say, this words of I have two options. If I am on specific I, either I can take it or ignore it. Let's say I was maintaining my, if the previous stuff, again, you never know what you have taken previously, but imagine previously, let's say you would have ignored this and would have taken this. So let's say I'm maintaining my, again, if you remember, I was maintaining my current word map, right? Current word map, which was same way saying you are maintaining your current word, like current corrective frequency for a subset which you have taken. So if I will take it, I should directly add all the characters in this current word map, right? If I ignore it, then I will pass on this, like I will simply pass on this current word map forward. So I simply can easily see that if I use my recursion, again, I'm not sure if it's recursion or backtracking, but if I use my recursion, something of that sort, I would simply be needing to iterate on 2 to the power n for all the subsets, which means this I plus 1 and stuff. And then at every point, if I include some specific word of I should simply incorporate the frequency of every character in the previous map. And I know the length is itself only L. So I can simply see by using recursion, I can maybe remove, if you remember earlier, the complexity has n also the factor. With that, with the simple recursion, maybe I can remove that n factor altogether. Okay, let's see the code for that, right? So what I will do, I'll simply say, bro, I will maintain my current letters map. Same way saying, I will simply iterate on the letters and maintain the frequency. Okay, for every character, what is the frequency? And then I will simply call my recursion by saying start from the index 0. This is my input words and score. Now I will use the same score. I will not convert the score to a map, just to showcase how we can use it. Then I just made this letters map. This is my word map. If you remembered, I will maintain the word map saying whatsoever subset I have taken, this is the frequency of every character in the existing subset, and now incorporate the current index I, which means words of I. Now let's go on to our solve function. Again, simple recursion. It simply says that, again, this is the inputs. All these are inputs. That's it. These are all inputs. Now, firstly, base case. As you can see, although I always recommend we come to base case in the very end. But the base case is very simple, that as soon as my words are finished, I can simply say I have got my subset. Whatsoever I need to get, it is one such subset for me. So I will now get the current score of a current subset, and you know the frequency of every character for our subset is maintained in the word map. The frequency of every character which they want us to follow is maintained in the letters map, and the score is in the score vector. The words is no more useful because I have ended and everything is in words map. So for me, words map and score is useful to know the current score, or basically the score of that specific subset. So I will iterate on the word map and I will find the current score by taking the frequency and the score from that specific score vector. Now, when I have got the score, So I will just simply say that, okay, my score is the max. I just simply maximize my score. My score is a global variable initialized with 0, as you can see. Cool. Now you will ask, Aryan, but you did not check this letters map. Yeah, correct. I will check it while I am building my answer. Why is that the case? It is the case because if you will do these checks while building, while recursing, then it will help you prune the recursive tree. If you don't know, again, I have taught it in these videos how pruning works, but pruning is simply knowing if your girlfriend is gonna break up with you, just break up with her before. That's the simple point of pruning. If you know after 1 month your girlfriend will break up with you, just right now itself, if you know there are symptoms of her cheating or doing anything, just simply break up now only, so as to not get that damage of extra time used, right? Your time is gonna be wasted. So prune it beforehand, which means prune while going to the recursion, which means identify stuff which is not good while getting the recursion. It's a reason. Okay, my base case is done. When I'm trying my recursion, I will check if it is okay. For the checking, for okay checking, I'm checking if I incorporate my current words of I in the existing subset, which is incorporating word map. If I'm in the existing word map, if I'm incorporating a new word, which is words of I, maintaining, okay, letters map should be maintained. I should not exceed my threshold. I also have a limit. I also have an ego. That ego should not be exceeded, right? That is what I will do, is check. Again, this is called as pruning, right? Now in this is okay, I will go and simply check that, okay, for the specific word map, I will simply iterate. And I will, again, this is, you will see I have passed by value. not by address. Why? You will see, because now I am modifying my words map. It's a reason. Okay, I could have made a temporary word map. That's a one possible option. But here you can simply see I have used existing same word map because I know I have passed this by value. That's a very big thing, right? Because I should add, okay, as you can see, I am iterating on my specific word and I'm adding the frequency of every character. And as soon as the frequency exceeds my limit ego, okay, I know I have to return a false. I have to break up right now. If not, then I'll simply return a true in the end. So with this, what will happen? My word map frequency is not changed. Even if I return a false or a true, my word map frequency will not change. Only when I know it is true. Only when I know, okay, she is good, he is good, like as in considering for her well. If I know that my partner is good, only then I will add the actual frequency for every of the character in that specific words of I. Cool. And then when this is added, I will simply go and ask my recursion, solve I plus 1, giving the new word map. Now, if you had known previously, or if you have watched this backtracking playlist, you know that if you have to solve it via simple recursion, then every time you will have to make a new copy of word map. Although this copy is only of size 26. So you will make at every level, you will be making, again, every level you will be making a copy of 26 characters. Level at max can be n, because I know my recursive depth can be go up till n. So n into 26 will be extra time used, extra space also used if I will use a recursion. I can remove this extra time and space by simply modifying my recursive code to a backtracking code and simply saying that, bro, what I should do is, I know this is a word map. I need to pass it by address in my recursive call. So I know that while coming back, I should remove, again, this is post my solve function, right? So while coming back, I should make sure that I remove the frequency, or I should remove those characters which I added before my recursion. So after my recursion, I just simply removed it. Again, if you're confused in this, simply this one video is more than enough for you to make you understand everything from top to bottom. Cool. Now this is okay if things were okay for me, and there is always one other case, that be single, which means just skip left swipe. So just skip that specific words of I, so it will remain as it is, and ultimately I have simple void function, so I will simply return a null. And that is how you will see, because of this I, my recursion will go to for n time, but as I am only checking for a words of I length, so this will go for length of L. This will again a length of L. Again, this is a if condition, so L into L will not be there. L plus L will be there. Again, this is for recursion, simply a 2 to the power n again. And again, this is for L. So for me, the complexity is 2 to the power n into L. Thus, a factor of n is removed here. But you will see, because of this recursion you are taking, you will incorporate a O of n extra space because of recursive depth, because of your I. And that is the reason you will incorporate a new space of O of n. Again, it is up to the interviewer if you want a different approach, but this is better time, but worse space. Cool. Again, time always plays more important role than space. So always make sure that, okay, you are sorted. And thus you can simply solve it by recursion, or you can say backtracking. Cool. I hope you guys got it. If yes, then please do share with your friends. It helps us a lot. I know the channel is not growing. I don't know why, but it will be very helpful if you can, again, if you found this helpful, if you have watched up till this point, it will be helpful if you can just watch it. Can smash the like button and can share with your friends. Bye bye.